Welcome to the Explainer. Today we're taking on a topic that is absolutely everywhere right now, but let's be honest, it's frequently misunderstood. For anyone looking to get generative AI explained for beginners, you are exactly in the right place. We're going to cut right through the hype today to answer two really big questions. What is generative AI, and how does generative AI work under the hood? From the exact moment you type a prompt to the astonishing new realities it creates, let's look at what this massive technological shift actually means for our future.
Okay, let's dive into this and look at our roadmap. We'll be covering 1. Unpacking generative AI, 2. How language models work, 3. Creating art and music, 4. Real-world industry applications, and 5. The economic impact and the future.
All right, Section 1. Unpacking generative AI. To truly wrap our heads around this technology, we first have to see exactly where it fits into the broader tech landscape.
Think of AI kind of like a set of nesting Russian dolls. At the very outside, the biggest doll, you have artificial intelligence. That's just the overarching goal of building smart machines. Crack that open, and inside is machine learning, the toolbox of algorithms that actually let a machine learn from data. Inside of that is deep learning, which uses these complex, multi-layered neural networks inspired by our own human brains. And sitting right at the very core, the innermost doll, is generative AI. So it's essentially a highly specialized type of deep learning.
Now, here is where we draw a hard line between traditional AI and the tech making all the headlines today. Traditional AI is discriminative. It basically analyzes and classifies things. You give it a photo, and its job is to ask, is this a cat or a dog? It just categorizes existing data. Generative AI, on the other hand, creates. It doesn't just classify the cat. You can tell it to draw a brand new cat wearing sunglasses, and it produces completely open-ended, original content, totally from scratch. But how does it actually create? Well, it's absolutely vital to remember that generative AI is a probability engine, not a logic engine. Instead of pulling a hard fact from some fixed database, it's statistically predicting the next pixel in an image or the next word in a sentence. It completely excels at creative mimicry because it mathematically calculates what should come next based on vast amounts of training data. But because it doesn't actually rely on rigid logic, it can sometimes hallucinate, meaning it'll give you answers that sound perfectly confident and plausible but are factually entirely wrong. Moving on to Section 2. How language models work. What exactly happens in that split second of silence after you type a prompt and hit enter? To get large language models explained simply, we can break it down into a millisecond pipeline. First is your prompt input. But here's the thing. Computers don't understand English, they understand math. So step 2 is tokenization. The AI literally chops your words into numerical values called tokens. A phrase like "the quick brown fox" is transformed into a sequence of numbers. Once it's all math, it moves into step 3, multi-headed attention, before finally decoding back into the content output you see on your screen.
And this brilliantly illustrates that process in action through mass diffusion. Look at how it starts with blanks, or masks, at time 0. As the model iteratively processes the data, it probabilistically fills in those blanks. By the time we reach step 1, it has successfully predicted and generated the coherent sequence, "the cat sat on the mat." It is systematically turning pure uncertainty into structure. Now, the true secret sauce making that sentence coherent is the attention mechanism. Before modern models, earlier AI would literally forget the beginning of a paragraph by the time it reached the end. Multi-headed attention fixes this by running multiple specialized searches in parallel, sometimes 8, 16, or even 32 heads simultaneously. One head checks grammar, another checks semantics. This is what gives the AI its context. It's why, if you type the word "it," the AI instantly looks at the surrounding tokens and knows if it refers to a country like France or a pair of skis. It weighs the relationships between every single word. It's worth noting, though, that not all of these models are built the same. You have massive, large language models like GPT-4 with hundreds of billions of parameters. They are brilliant generalists capable of really complex reasoning, but they're expensive and slow. On the flip side, we have small language models, or SLMs. With fewer than 7 billion parameters, they might lack vast world knowledge, but they are incredibly fast, super cheap, and can operate directly on your smartphone, which ensures absolute user privacy. All right, Section 3, Creating Art and Music. We've mastered text, so let's shift gears and explore AI-generated art, music, and stories by looking at a core process called diffusion. Now, what's really interesting about this is the exact aha moment of diffusion models in AI.
Look at the pure, unrecognizable static noise over there. Step by step, the AI applies a really complex mathematical process to iteratively strip away that noise. By the end, that pure static has been converted into beautifully structured, recognizable handwritten digits, a 2, a 3, and a 6. This exact same principle of denoising is the core text-to-image AI technology used to generate hyper-realistic photos and videos.
And guess what? It works for audio too. Just look at the sheer versatility of AI music generation systems like DeepMind's Lyria 3. We're not just talking about generating simple 10-second beats here. It generates full 3-minute high-fidelity tracks and simulates highly nuanced human vocals across multiple languages. You can even upload an image and have it compose a track based purely on that visual. And, importantly to address safety concerns, models like this embed imperceptible Synth ID watermarks directly into the audio itself.
Section 4. Real-world industry applications. So we know the mechanics, and we've seen the creative outputs. Now let's zoom out and look at the actual applications of generative AI in industries all around the globe. In healthcare and biology, generative AI is absolutely a game changer. It's accelerating research pipelines that used to take years down to days or even hours. AI is being used to simulate disease progression, helping doctors gain much faster insights. It's creating highly realistic synthetic medical data based on real patient profiles to train healthcare workers without ever violating patient privacy. And on a cellular level, models like AlphaFold 3 are predicting atomic-level protein structures, while others are literally simulating 500 million years of evolutionary DNA to unlock the secrets of biology. Crazy, right? Over in the software and coding sector, generative AI treats programming languages just like English or French. Because code is ultimately just text, developers are using models like GitHub Copilot as collaborative assistants. You can literally write a natural language instruction, and the AI translates it directly into functional Python or C++. Conversely, you can feed it a massive, complex legacy codebase, and the AI will summarize exactly how it works in plain English. It is drastically reducing the time needed to build and maintain complex software.
Finally, Section 5. Economic impact and future. With applications this undeniably powerful, the macroeconomic shifts are going to be staggering. Let's look at the sheer scale of the economic forecasts based on recent data from KPMG.
$11.04 trillion. Let that sink in for a second. That is the massive potential added growth to the global economy by the year 2050. When we talk about the future of generative AI, this isn't just some incremental tech upgrade. We are looking at a foundational shift in global productivity. Breaking that economic growth down geographically, we can see exactly where these gains are concentrated. The U.S. stands to gain a projected $3.38 trillion in GDP by 2050, with Europe following closely at $2.72 trillion. These gains represent massive surges in productivity across huge sectors like education, healthcare, and transportation, all driven by the multiplier effect of AI investments.
So the crucial point is, when evaluating the benefits and risks of generative AI, we really have to ask, what does this mean for us, for human workers? Well, KPMG's data contrasts two very different labor market scenarios. If we see rapid AI adoption with a massive commitment to retraining the workforce, we project a net gain of over 8 million U.S. jobs by 2050. However, if industries rapidly adopt Gen AI without upskilling their people, we face a net loss of around 1 million jobs. The technology is ready, for sure, but human retraining is an absolute necessity right now.
Which brings us to a final, really provocative thought. We started out today by defining generative AI as a probability engine, a system that uses math to predict the next token or the next pixel based on vast sets of human data. But as these models masterfully generate award-winning art, write incredibly complex software, and compose high-fidelity music, we have to ask ourselves, where exactly is the line between brilliant statistical mimicry and genuine human creativity? It's something we're all going to have to navigate together as we step into this new reality. Thanks so much for joining me on this explainer, and keep learning.